Hi everybody, welcome to lesson 26. This is the second lesson in our second unit. So make sure you've already watched lesson 25, where we learned about factoring out a GCF, and we also learned about factoring by grouping. This next section, as well as the one after it, will really focus on trinomials. Tri meaning three. So we're going to focus on polynomials that have three terms, and there's some different approaches to factoring that we're going to learn. In this particular lesson, we're focusing on trinomials that have a leading coefficient that just has x squared or just a variable squared with the leading coefficient 1. So that's why we're saying a equals 1 in the title of the lesson. So the trinomials we're looking at, instead of being written as ax squared plus bx plus c, we're really focusing first on the ones that appear not to have any coefficient, that there's just a 1 here. I'm mentioning this now because not all trinomials look like this. When we get to lesson 27, we will see trinomials that have a number here, like a 2 or a 5 or something. And I just want to say right now, before we dive in, that the process that we use for those trinomials will be different from what we're seeing right now. Okay, so let's take a look at our first type of trinomial. So we're going to be factoring a trinomial of the form I almost said it, x squared plus bx plus c. Okay, the a, it's really there. The a is just 1. Okay, so we're not seeing it, right? So notice number 1 and number 2 down here, they both just start with x squared. So we're focusing on that kind. Okay, so factoring a trinomial of this form will result in the product of two binomials. Bi meaning two terms. Okay, so x plus a number times x plus a number. Now just a little note here, it doesn't necessarily have to be plus. We could have minus signs as well. We'll get to that. But what we're really going to be noticing in this section is we're going to be focusing on FOIL, but in reverse. That's kind of the main idea. So instead of distributing and multiplying two binomials together like we've already done, now we're going to start with a trinomial and end with our two binomials. It's sort of the reverse of some of the questions you would have answered on our first test and some of the things we learned about with multiplying polynomials. Let's look at some steps. Okay, so step 1, find two numbers whose product equals the constant c. Okay, c meaning the last term. So the last term. Okay. And whose sum equals the coefficient of the x term b. In other words, the middle. Okay, so a couple of vocabulary words here. Product, that refers to multiplication. So just a little reminder about what that word means. A product is an answer to a multiplication problem, whereas a sum is an answer to an addition problem. So the question we'll be asking ourselves over and over is, what are two numbers that multiply to blank and add to blank? So we'll get to some examples here in a minute, but we're going to be kind of running through some lists of possibilities of numbers that have a certain product while also having a certain sum. We're going to get to this. Okay, we're still in the introductory part. Okay, and then once we find those numbers, I mean, step 1, that's the work of the problem. Once we find those numbers, then we're able to pretty much fill in our answer. So use these two numbers to write the trinomial in factored form. X plus one number times x plus a second number. If those numbers happen to be negative, we might have minus signs rather than plus signs. Okay, and if no such number combination exists, the polynomial is prime. So sometimes after all that work, we will find that there is no such combination of numbers. And that means the trinomial is not factorable. And if it's not factorable, we call that prime. That's sort of a way of saying that there's no solution. But prime is very specific in what that means. It's not factorable. So let's see some examples. All right, we're going to do just two kind of quick factoring examples, and what we will see is that really there's kind of a step 4 here, which is to check our answer using FOIL. So check with FOIL. Check by distributing, basically. Okay, so we're gonna factor and then we'll check. The next slide that we see, we'll just revisit what we mean by FOIL and distributing and just make sure we're really solid on what that is, because understanding multiplication and distributing is really key to understanding factoring as well. Okay, number 1, here we go. So x squared plus 9x plus 20. Now, keep in mind, what are the types of factoring that we learned before this in our previous lesson? We learned about factoring out a GCF, greatest common factor. Notice that there is no GCF here, okay? There's no common factor that's present in all 3 terms. I realize that the first 2 terms have an x, but the last one does not, okay? And also notice the number of terms. This is not a grouping problem right now. It does not have 4 terms. It has 3 terms. Trinomial, tri means 3. So we're not really able to use those other methods right now. So let's refer to our steps. So we're going to find 2 numbers whose product equals the constant c. So we want our product to be 20 and whose sum equals the coefficient of the x term b. So we want our sum to be 9. In other words, here's what we need to think of. We need to find 2 numbers who multiply to 20, but also add to 9. I'm sure some of you watching this right now, you already thought of those numbers. It just came to you almost like it was magic. Okay, this is not magic. So this is usually the time in the class when, if we're all in the same room together, I'd say, hey everybody, if you're noticing that somebody's already shouting out the answer or somebody already knows the answer and you don't know what's happening, that's okay. Basically, the more, how do I say this? The more comfortable you are with your times tables, the easier this will be. But that's not a change that can come to you overnight. So just be ready to practice and everybody will get better at this. If you've never seen this before, try to be patient with yourself. We'll do plenty of examples. So if you already know the answer, that's great. I'm going to temporarily switch over to my whiteboard here and show everybody how you can work through this without feeling like you're just randomly guessing. Okay, so x squared plus 9x plus 20. Okay, so here's what we're trying to find. I'm going to type it out. So we need 2 numbers that multiply to 20 and add to 9. That's what we need. Okay, so you can kind of sit there and think, or there might be an actual process we can go through here. All right, so here's one of the ways we can systematically come up with our combination here. All right, I'm going to make a little chart. Nothing fancy. Product and then sum. So we want our product to be 20 and our sum to be 9. So here's what I usually do. I start listing, let me write that better, sorry. I start listing factors of 20. I start listing numbers that multiply to 20. And I'm going to start with 1. 1 times 20. Those are 2 factors of 20. They multiply to 20. 2. 2 times 10 is 20. 3 would be my next thing in my list, except 3 doesn't go into 20, so I'm not going to include it. So 1, 2, 3 doesn't work. 4 times 5 equals 20. And then next in my list would be 5, except look, I already have it. So this is a complete list of factors of 20. Okay, now I'm going to add them. And that's where I fill in the rest of my chart here. When I add these factors of 20, 1 plus 20, let's see what I get for my sum. 1 plus 20 is 21. 2 plus 10 is 12. 4 plus 5 is 9. Now, remember what we were looking for. We were looking for factors of 20 that add to 9. Here they are. Okay, so the 2 numbers are 4 and 5. Those are the ones that add to 9. So if you remember sort of the structure of our answer, the structure of our answer will look like this. We'll have parentheses. we'll have two parentheses, two binomials. And what we saw before is, for right now, the structure of our trinomials, they're going to start with x squared for the most part. So we need x times x in our first part of our parentheses. That's kind of a given right now. What we were really trying to come up with is these other numbers. So x plus something times x plus something. What's going to go here? We just found the numbers that we will fill in. Okay, so it's going to be x plus 4 times x plus 5. And remember, we came up with those numbers because they multiply to 20, they have a product of 20, and they have a sum of 9. So this is our final answer right here. X plus 4 times x plus 5. You could also write it in the other order. You could write the x plus 5 and then x plus 4. That's the same thing. The last thing we should do is check to see if this is actually correct. We need to check to see if our factors, when we multiply them together, do they actually equal our original trinomial? So that's what I meant by check by using FOIL. And I think we did that in our factoring by grouping lesson as well. So I'm going to FOIL, I'm going to distribute. Remember, when I say FOIL, that just stands for first, outside, inside, last. So I'm going to check my first two terms, x times x, that's x squared. My outside terms, x times 5, that's 5x. Inside terms, 4 times x is 4x. And then finally, the last two terms, 4 times 5 is 20. So notice I do have those 4 terms. A lot of times when we FOIL, the middle two terms can be combined. 5 plus 4 is 9, so there's our 9x. So see how that 5 times 4 multiplied to 20, and right here, when I'm combining like terms or collecting like terms, that's the sum part of this, okay? So that's when they're adding up to 9x. Okay, so x squared plus 9x plus 20. So this is verifying that yes, those two binomial factors do in fact multiply together to equal the original trinomial. Okay, so that's our first example. Going back to my notes here. So that all would have maybe gotten written on the side or on a different page or something. So here's my answer. Okay, my final answer is x plus 5. Oh wait, I think I said x plus 4, sorry. X plus 4 times x plus 5. Or x plus 5 times x plus 4. Both of those are equal. So I'll just say or. Either one of those is fine. All right, let's do one more that's similar. Okay, so we'll go to number 2, x squared plus 10x plus 25. So once again, we can set up our parentheses. It's going to be x plus something times x plus something. So x plus something and x plus something. The somethings, okay, those are the numbers that we need to come up with. So we need to find two numbers whose product equals the constant c. So this time our product is 25. So we need two numbers that multiply to 25. And those two numbers also need to have a sum of 10. All right, now I could go back and do the same kind of little chart that I did before. 25 doesn't have a lot of possible factors, so I can probably just kind of squeeze that in right here. Factors of 25, 1 times 25 would work. 2 doesn't go in, 3 doesn't go in, 4 doesn't go into 25. The next pair of factors would just be 5 times 5. And then I've got my complete list. So that's not really a long list of factors. You can see if I add them together, 1 plus 25 is 26. That's not going to work. 5 plus 5 is 10. Here it is. These are the numbers that will work. So my final answer here will be x plus 5 times x plus 5. Again, the way I came up with those two numbers is they have a product of 25. They multiply to 25. And 5 plus 5 adds to 10. And if we were to check this using FOIL or using the distributive property, the 4 terms we would get, here's what they would be. X squared, so here's FOIL, plus 5x plus another 5x plus 25. First, outside, inside, last. And notice when we combine those middle terms, 5x plus 5x, there's your sum of 10x. One last note on this problem, x plus 5 times x plus 5, those two factors are actually equal to each other. So let me make a little bit of space. I'm erasing where I checked because I want to have space to write another way of writing the answer. Because the two factors are equal to each other, another way of writing the answer is using an exponent. So you could also write or x plus 5 squared. Okay, so both of those answers are correct. You may use either one for your answer. Okay, so you can use the exponent, or it is okay to write them separate. X plus 5, x plus 5. All right, so this, I feel, is the kind of thing that would be good to just practice almost in an old school fashion of now go do 100 problems. That might be a little extreme, but you just need to kind of practice these over and over and over. So you might consider, as you're working through the homework, if you're struggling, don't be afraid to maybe click similar question and just do that question again, and then do it again, and then do it again, and just kind of get that practice with a lot of different types of numbers if you need to. All right, good. So next slide. Now we've talked about a little bit, we've talked about checking our answer with FOIL when we're factoring. Sometimes I start the lesson this way when I've taught this before. I decided to show you a little bit of factoring first, but I'm kind of pausing here to sort of remind you the connection between multiplying and factoring. So that's kind of the goal here. All right, so it's sort of like, side note, remember FOIL, because that's very, very relevant. Okay, so this is meant to be a review, just quick review of FOIL, multiplying binomials. Okay, so we just did that for our previous two examples, but we'll do it again. X minus 3 times x plus 4. So go ahead and just distribute those, nothing new here, just some practice. Okay, so we'll practice distributing. X times x is x squared. X times 4 is 4x. Now there's a minus sign. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. When I combine those middle terms, positive 4x minus 3x is positive 1x. But a lot of times we don't write the 1 in our answer. We just write this, x squared plus x minus 12. So in just a minute, we're going to see this trinomial and practice factoring it. Okay, so if we were to factor this trinomial, we would be coming up with, let's see, we'd go x times x. We'd come up with factors of negative 12 that add up to 1. Now, how could factors add up to 1? Well, here they are. They really need to have a difference of 1 in a way. 4 minus 3 was 1. So once negatives come into play, it does get a little bit trickier. We'll see that problem very soon on the next slide, I think. But I just want you to see the connection between FOIL, multiplying. Notice that we're multiplying a binomial times a binomial. That equals a trinomial. And again, I think I've already said this, but binomial, the prefix bi just means 2. So there's 2 terms in each of these, and then tri means 3. So there's 3 terms in the final answer. All right, number 2, y minus 8 squared. We did learn a formula for squaring a binomial. What I'm going to do though is, rather than using the formula, I am going to write it twice and then FOIL. This is something we've done before. So distribute y squared minus 8y minus another 8y, and then negative 8 times negative 8 is positive 64. In this problem, the middle terms, when I combine them together, negative 8 and then negative 8, that equals negative 16y. So my answer becomes y squared minus 16y plus 64. This is another trinomial that we might see in a factoring question. So we might be asked to factor the trinomials above, and then our answers to the factoring problems would be what we started with here. So it's all kind of one big cycle. We already learned how to multiply in our previous unit, and now we're learning to undo that by factoring. All right. Good. So let's move on and see some more factoring examples. All right. All of these problems, just to keep things maybe a little bit simpler, all of these problems involve 12. Okay, so 12 has more than one pair of factors. So we're just going to go off of one list here. So I did write a little note here. First, list all factors of 12. So I'll make that little chart that I did before. That's my product. And then my sum, it's going to be different for each problem. So I'll kind of leave that blank. So let's make a list of factors of 12, kind of off to the side here. All right, let's see. So we'll start with the one that we always forget about, which is 1 times 12. It's probably not the first one you thought of, but I like to list that one first, just to kind of keep things in order. Then we'll go to 2 times 6. Then we'll go to 3, which is 3 times 4. The next one would be using the number 4. It would be 4 times 3, but we kind of already covered that. Okay, so this is it. And then if we add up these pairs of factors, we'll have our sum. 1 plus 12 is 13. 2 plus 6 is 8. 3 plus 4 is 7. Okay, good. All right, so this is a list we can refer back to. Let's see if we can factor each of these polynomials. And remember, a polynomial just means something that has many terms. It could have really any number of terms, including 3. So these are all trinomials, which is just a specific kind of polynomial with 3 terms. All right, so with each one, I would try to factor it into 2 binomials. So each one of these problems I can start, because each one starts with x squared, I'll put x times x for my first terms, kind of imagining that I'm FOILing or distributing. My outside and inside terms need to have a sum of this middle term. They need to add up to 8x. Okay, and then my last 2 terms need to multiply to 12. So we go to our list here. Let's find the factors of 12 that have a sum of 8. Here it is right here, that second one in the list, 2 and 6. Okay, so I would put 2 and 6 here. And again, those numbers have a sum of 8, and they have a product of 12. This would be my answer, x plus 2 times x plus 6. Or I could write x plus 6 times x plus 2. Either order is fine. When I distribute, I would get x squared plus 6x plus 2x plus 12. Here's my sum that I'm looking for. Those middle terms need to add up, need to add up to 8x. And of course, they multiply to 12. Let's go to number 2. Start with x times x, because that multiplies to x squared. Okay, and just a little note, all the problems on this particular slide, they all involve plus signs. We'll deal with negatives soon, but we're not quite there yet. I now need 2 numbers that have a product of 12. And when I FOIL, when I multiply, the outside and inside terms need to have a sum of 7x. So the numbers need to have a sum of 7. Here they are, 3 and 4 from my table. Okay, so I'll do x plus 3 and x plus 4. Once again, you can write the answer in the opposite order if you prefer. It does not matter. And once again, I'll check using FOIL, x squared plus 4x plus 3x plus 12. And there's my middle terms adding up to 7x. All right, good. Number 3. I mean, if you're paying attention to the table, we're kind of just down to one last option here. So let's see what we got. X times x is x squared. This would be a problem that I would expect students to struggle with. There's something about seeing the number 13 that people think, oh, 13 is prime. Like, what are we supposed to do with that? 7 was prime, and that was fine, right? So don't be afraid of seeing prime numbers in here. Remember, we're looking for factors of 12 that have a sum of 13. It's this first option, 1 and 12. 1 times 12 is 12. And 1 plus 12 adds up to 13. So if we check it, x squared plus 12x plus 1x, you can write plus x if you prefer, but it is 1x, and then plus 12. These do add up to that 13x. All right. So that brings us to number 4. We already made a complete chart here with all the possible factors of 12. None of them add up to 5. So this trinomial is prime. You might have tried something, but no matter what you try, nothing's going to work, okay? No combination will give us that sum of 5x when we FOIL. So this polynomial is not factorable. We would call this prime. When you get to a problem like this on the homework, it will be an option that you can choose. Choice A will be to type in an answer. Choice B will be to just type or just choose prime. Okay. So sometimes those prime ones are the most frustrating because you kind of need to work through a bunch of different possibilities until you just come to the conclusion that, oh, this one's not working, therefore it's prime. But I will say it can be hard because you might feel like, well, is it prime or is it just me? Maybe I can't do it. There's a difference between I don't know and there's no answer at all. Okay, so just be aware, and that's why it's a good idea to really make a complete list of all your possibilities. Make sure you check all of them until you conclude prime. You don't want that to just be something that you're guessing. Okay, so we're gonna move on and see a couple others that don't have to do with the number 12, but hopefully you're maybe getting a tiny bit more comfortable as we go. All right, so we have a couple more examples here. Now we're starting to branch out and not use x all the time, and we'll see a little bit more variety. Number 1 in this next set, c squared plus 4c minus 32. All right, so once again, I am going to set up some parentheses. Oops, sorry about that. It's just that this time when we set up our parentheses, instead of x, we're using the letter c. C times c is c squared. Now to come up with my other numbers, this time I need my product to be negative 32. Okay, so now it's getting a little bit trickier because once you're dealing with negatives, suddenly your list of possibilities basically doubles. It becomes twice as long because you need to consider all different combinations with your signs. But that's okay. All right, here we go. So I'm going to make my full list here, starting with 1 times 32. Okay, so 1 times 32. Except 1 times 32 is positive 32. So in order for this to work, one of these numbers needs to be negative. Which will it be? Well, let's start with negative 1, which means I also have to consider the other possibility that it could be negative 32. That's what I mean by my list is now doubling. Okay, next we'll do 2 times 16. Could be negative 2 or negative 16, either one. Next on the list, we'll check if 3 is a factor of 32. 3 does not go into 32. You can just do a quick check on your calculator. 32 divided by 3, it's a decimal. We don't want that. So we'll move on to 4. 4 times 8. We'll do 1 with the negative 4 and then 1 with the negative 8. Next on the list would be 5. That's not a factor of 32. 6 is also not a factor of 32. 7 is also not a factor of 32, which brings us to 8, which we already have in our list. So this is our complete list. And you can see if this was positive 32, I'd really only have 3 combinations, but since it's negative, again, it kind of doubles my list. Okay, so I want my sum to be positive 4. All right. I can kind of start narrowing it down here. Negative 1 plus 32 is not 4. 1 plus negative 32, also not 4. It's going to be one of these with the 4 and the 8. Okay, Okay, so as you're working through your list of factors, I recommend always start with the ones that are closest together. The ones that are farther apart, like 1 times the number, those are sometimes the answer, but those are less likely to work. Okay, so I might actually start down here. I'm going to now find the sum of these factors. 4 plus -8 is -4. -4 plus 8 is 4. This is the one. Okay, these are the numbers that will work. So I don't necessarily need to check any of the others, but just to be thorough here, I will. If I find the sum of all the others, 2 plus -16 is -14. -2 plus 16 is 14. This is going to be -31. This one's +31. Okay, so the only combination that has not just a product of -32, but a sum of +4 was this one right here with the -4 and the +8. So that means I get to write C -4 and C +8 as my final answer. Again, those two numbers have a product of -32. They multiply to -32. And when I FOIL, my outside and inside terms need to have a sum of 4. So let's check it. Again, we can check by distributing. So C squared plus 8C minus 4C and minus 32. So that's my FOIL checking right there. Here's my middle terms. 8 minus 4 is +4. So with negatives, it's really easy to get the signs mixed up. So if somebody were to make a mistake, I would expect maybe instead of writing C -4, you might accidentally write C +4 and C -8 and just mix up the signs. The signs are absolutely important, okay? Now, if you wanted to write the answer in a different order, here's what you could do. You could write the C +8 first and then the C -4. But it's important that the 4 has the minus sign and then the 8 has the plus sign. All right, I'm going to do one more with you and then I'm going to pause. I think I will just break this video up into 2 parts. I feel like I'd be reaching the point in class where we'd be maybe needing a break, but there will be a part 2 after this. Okay, so number 2 on the slide we're working on. This one should look very different to you. It should look out of order. We want our trinomial to be in descending order. We want the squared term to be first. So if you go back to our first slide, it was x squared plus bx plus c. So the x squared should come first. In this case, it's w squared first. Then the next highest exponent would be just the w, so 2w, because that technically has an exponent of 1. Our last term will be the constant term. Constant meaning there's no variable, it's just a number. All right, and now we'll set up our parentheses. Okay, last time we were able to start with C at the beginning of each of our parentheses. This time it'll be W. W times W is W squared. This time we need our last 2 numbers to have a product of -24 and a sum of 2. Okay, make my little chart. Again, I'm sure some of you can just sit there and think of the numbers, that's fine. But I'm trying to show a systematic way of getting there if you can't just think of them automatically. Okay, I'm gonna make a slightly, a slightly abbreviated list. Last time I really listed them in more detail. I'm going to maybe not list all the different signs. Let me show you. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so here's often how I work through this. I haven't put any signs here. I know that when I'm multiplying to a negative, in order for these numbers to multiply to -24, they need to have opposite signs. They need to have different signs. So I need 1 positive, 1 negative. Okay, I also know that the numbers need to add up to +2. So if my sum is positive, that means I'm going to say my bigger number will be the one that's positive, right? If you're trying to look for a sum that's positive, if you want your numbers to add up to something positive, then between the two, whichever one is bigger, that's the one that would be positive, which means the one that's smaller would be negative. Okay, if you could follow that, that's great. If I lost you there, you can just make the full list like I did before. So -1, 24, 1, -24, -2, 12, 2, -12, etc. But I kind of like to make this shortened list, and then based on the sign of my sum, that's the one that will be positive. So each one of these sums now, when I add them, they should all add up to something positive. So let's work through it. -1 plus 24, that's positive 23. -2 plus 12, that's positive 10. -3 plus 8, that's positive 5. And then -4 plus 6 is positive 2. This is the one. Okay, so -4 times 6 is -24. -4 plus 6 is positive 2. So I can write W minus 4 and W plus 6 for my answer. And just like last time, you can switch the order of your answer. If you wanted to write the W plus 6 and then W minus 4, that would be fine. Notice that the signs need to not change, right? So the 6 definitely needs to be positive. The 4 needs to be negative. If you accidentally switch the signs, then you'd get -2 for your sum instead of positive 2. And just like last time, we can check by FOIL. All right, so we are still in the middle of lesson 26 right now. If this was a regular class, I'd probably say, let's take a break, come back in 5 or 10 minutes, and then we'll continue during our same class period. So everybody take a break and then come back, and you're gonna watch part 2, because there is a part 2 where there's more to do. Okay, so end of part 1. I'll see you very soon for part 2.